All right, here we go. Here's your test review. So to write the equation of a quadratic function in vertex form. Remember, vertex form is y equals a parentheses x minus h squared plus k. So as the function passes through the point, your point is your x and y, 1, negative 10. And it has a function, the function has a vertex, that's your Hello Kitty, hk, at 3, negative 7. Identify the values of a, h, and k. So there's my equation. We already know my h is 3. We already know my k is negative 7. So we just need to solve for a now. Well, y is negative 10 equals a, parentheses, my x is 1. For your h, remember it's always the opposite. The opposite of positive 3 is negative 3 squared. And then my k is negative 7. Next thing I do is just plug this one part into my calculator. To save some time, I'm not going to plug it in. I'm going to tell you it's going to be 4. Negative 10 equals, I should plug it in. I shouldn't be lazy. Okay. So I'm just plug in parentheses 1 minus 3 squared. There's your 4. Okay. So my 4 goes in front of my a for a minus 7. Now it's just solving equations. Draw your line of balance. The opposite of minus 7 is plus 7 on both sides. This is negative 3 equals 4a. We want to get the a by itself, so we're going to divide both sides by 4. Negative 3/4 equals a. So our a value is negative 3/4. If you do not put your answer as a fraction, I think it'll count it wrong. Sliding to question 2, it says read each statement below and select all the statements that are true. It says the coordinates of the y-intercept are at 0, 6. So I'm going to go to my y-axis. It does turn out my y-intercept is at 0, 6. So that is correct. It says the axis of symmetry is at x equals 8. Well, x equals 8 would be all the way over here. So it's not that one. One of the x-intercepts is at negative 6, 0. Well, I do have an x-intercept here at 2, 0. And yes, I also have another one at negative 6, 0. True. The function has 2 zeros. Remember, zeros are x-intercepts. So yes, we do have an x-intercept at 2 and negative 6, so that's also true. The point negative 2, 8 represents the minimum. Remember, minimum is your lowest value. This is not our lowest value, so it cannot be that one. This is the maximum. It's our highest point. The vertex of the function is at negative 2, 8. Yes. Scootin'. Or the next one says, what are the domain and range? So I'm going to go ahead and plug that equation into my calculator. Y equals negative x squared plus 6x minus 1. Well, if I'm looking at this one, domain goes left or right. So if I zoom out, there's nothing stopping this graph from going left and right. So our domain is all real numbers. So I'm going to go back here and get rid of anything that does not say my domain's all real numbers. So B is out and C is out. Well, for my range goes bottom to top. There's nothing stopping this graph from going down. We've already seen that. But I do have a maximum point at 8. 8's the highest we can go. So it can be 8 or it can be smaller than 8. Our math way of saying that is y, because domain is x, range is y. Y is less than or equal to 8. So our answer for this one has to be D. It says, what is the minimum value? Once again, remember minimum is my lowest point. Remember, it does not want the point though. If it's asking you for a minimum value, it wants to know what your lowest y is. Well, my lowest y, the furthest down we can go, is just negative 60. So it's not asking for your minimum point, it wants your minimum value. Going ahead and flipping, and I know I'm going kind of quick, but also, Y'all gonna be coming to class soon, and I did not record this yesterday. Oh. Okay. The graph of the function f of x equals x is transformed. So we have f of x equals x to form function g of x such that g of x equals 3 f of x. So I'm going to go ahead and plug that in so I can take a look at them. So we got here f of x equals x. And I got here g of x equals 3 f oh my gosh, 3 f of x. Okay, so green is my, for me, green is my f of x, purple is my g of x. I need to see which graph matches. Well, A and B obviously do not match at all. So it's not A, it's not B. And they even labeled it F and G for you. That means it has to be one of these two. Well, if I go back to my graph again, it's saying here, g of x, my purple one, should be the one that's up top. So this one says f of x is on top. This is the one that says that my g of x is on top. So our answer for that one should be D. Sliding over here, they gave us a table, and they want our quadratic formula. I know it's quadratic because it says squared. So we're going to use our y1 squiggly line, ax1 squared plus bx1 plus c. So plus sign table, I'm going to get all those points in there. 5, 10, 15, 20, what are we going to, 40? 25, 30, 35, 40. Oh my gosh. Okay. And then for my y's, we got 3, 10, 17, 27, 44, 64, 86, and 112. Plug in down here, y1 squiggly line, ax1 squared plus bx1 plus c. And I'm going to write down that my a equals 0.072. My b should equal negative 0.148. And my c should equal 2.732. So these aren't going to be exact matches. We're going to find whatever's closest. Well, this is out. That one's out. So we got these two. That looks great. My b is negative 0.148. It looks like they rounded it up to negative 0.15. There's my 2.73. Our answer should be B. This one doesn't have my B in there. Okay, the graph of the quadratic parent function was graphed to create this. Remember, these are your parabola shapes. This is quadratic. So if you wanted to plug it in, it would be f of x equals x squared, and then g of x equals f of x plus 2 minus 5. So one way you can do it is plug it in and go find your match. Or you can know inside your parentheses tells you left or right. It's always the opposite. So this means we're going to go left 2. This minus 5 on the outside tells you up or down. And it tells us we're going to go down 5. So the two ways you can do it are either go plug it in and find your picture, or just remember your transformation rules and find it that way. So f of x equals x squared. G of x equals f of x plus 2 minus 5. And we're focusing on the red one because the black one's the original. I'm looking for the one that matches my red one. So that should be C. Or this is the only one that moved left and then down 5. It moved left 2, down 5. So you got options. All right, on this one, they gave us a table. I'm going to go ahead and plug in that table so I can look at what it looks like. Plus sign table, so they gave us 1/2, 1, 3 over 2, 2, 5 over 2, and 3. Then for my y's, it's 7 over 4, 4, 19 over 4, 4, 7 over 4, and -2. And, whoa, what did I do wrong, yo? Oh, I put 3 over 3. What is this supposed to be? 3 over 2. It still looks wonky. What the heck? 1/2, 1, 3 over 2, 2. There we go. Oh my gosh. Okay. And I can always click on this magnifying glass and it'll zoom in to show us our points. It wants to know our range. Range is bottom to top. Well, first of all, I do know I have a maximum. I have a highest point. My maximum point right here is at 1.5, 4.75, which in this case, this is our vertex. Remember, vertex is the only one that doesn't have a symmetrical pair. It's the middle of all your pairs. So see 4 and 4, 7 over 4 is 7 over 4. If we continue the pattern, it would be -2 and -2. The ones that's in the middle of your symmetrical pairs is 3/2, 19 over 4. So this is our vertex, which in this case is our maximum. So that means I can be 19 over 4, or I can be smaller than that. Our math way of saying that is y is less than or equal to 19 over 4. B. For your domain, so remember range is bottom to top, domain goes left to right, it's your x's, range is your y's. Well, the furthest left we can go is -2. The furthest right I can go is 3. So that would be -2, 3, write x in the middle. Put my less than signs. Because they are closed circles, it's or equal to. So we're looking for -2x is less than or equal to x, which is less than or equal to 3. What's up? You're good. I was going to ask you if you had patty paper. We need patty paper so hard. Yeah, I don't have it. All right, thank you. Okay. Same thing. They gave us another table. So I can always go and plug it in. So let me go erase this. Okay, so we got 0, 0.25, 0.50, 0.75, 1, 1.25, 1.50, and 1.75. And then we got 0, 2.76, 4.94, 6.43, 7.35, 7.66, 7.35, and 6.43. Okay, so here's our graph so far. So for our range, once again, we know we have a maximum. I have a maximum right here at 1.25, 7.66. So I know right here, this is my vertex, and it's our maximum. So we can be 7.66, or we can be smaller than that. But you also have to keep in mind, this one's not just a table. They included a word problem with it. It says a ball is placed in a machine that throws the ball up in the air. The table represents some points on the graph of a function that models the ball's distance from the ground with respect to the time since the ball was thrown. So if you're thinking of the real world, our ball started here at 0, 0. It went up in the air, and it came back down. In the real world, it's not going to go past 0. And we already said our highest point was 7.66. So it has to be between 0 and 7.66 for this one, because it's attached to a real world problem. So our range for this one is going to be h. I can draw us a sketch of this one too. On this one when we did it, it looks like this. I know it had dots, but it looked like this. And our highest point was at 19/4. But because there's no word problem attached to this, it can be 19/4 or smaller. There's no limits on it. There's nothing stopping it. This one has the real world actually stopping it. The ground stops. The ball's not going to go through the ground to the center of the earth and all the way through to the other side of the earth. That's not how it works in the real world. Okay. Once again, here's a domain and range question. Domain and range. Remember, domain is left to right. It's your x values. Well, there's nothing stopping this graph from going to the left or right. So we call that all real numbers. So anything that does not say my domain's all real numbers, we can get rid of, which in this case was all of them. Let's talk range though real quick. On this one, we had a minimum value. The lowest we could go was 5. So I could be 5, or I can be bigger than 5. Our math way of saying that is y is greater than or equal to 5. All right, here's another one. They gave me an equation, so I'm going to go plug that in. Did you find some? Oh my god, we're saved. Thank you. So we got y equals -1/4, parentheses, x minus 17 squared plus 61. Whoa. So this one I'm going to have to zoom out some. So there's my graph. There is nothing stopping this graph from going left and right. I can zoom out as far as I want and it's going to keep going. So my domain should be all real numbers. So we can get rid of g and j. Now for my range, let me go back. Let's see, we have a maximum. We do have a highest point. It says my highest point is here at 1761. Well, if you look at both of our answer choices, it has both of those numbers. But first of all, H says X, your range is not your X, so that should automatically be gone. So our answer should be F plus range is your Y, X, Y. So it can be 61 or it can be smaller than that. So it should be Y is less than or equal to 61. Oh, I got 4 minutes to finish this before y'all come. What is the y-intercept? That should be quick and easy. We've done y-intercepts so much. It crosses my y-axis here at 4. Our answer should be C. How many more I got? Okay, I'm on the last 2. I might be able to do this. Okay. For this one, they said f of x equals 1/3 4 minus x squared. And they also told us g of x equals 3x minus 12. Which of the following statements is true? So here's what we're going to do. This is a calculator question. It looks complicated. I promise it's not. On answer choice A, what do they both have? 7. So here's what I'm going to do in my calculator. In my calculator, I'm going to plug in f of x equals 1/3 parentheses 4 minus x squared. And I'm going to put in f of 7. That gets me 3. Now I'm going to plug in g of x. G of x equals 3x minus 12. And I'm also going to put g of 7. So I got 3 and 9. Are those equal to each other? No. So A is out. So next thing I'm going to do is check 4. I'm going to check 4 for both of them. So I'm going to put f of 4 for this one. That gets me 0. And g of 4. Are 0 and 0 the same? Yes. So that's probably our answer. I'm going to put a maybe. Let's check 9 real quick. I'm going to go put 9 for both of them. F of 9 and G of 9 Those are definitely not the same number. So that one's out. Then I'm going to check 8. 8. Check 8 on this one. Once again, they're definitely not the same number. So don't let that one freak you out. That's all calculator. Our answer is B. Final question. It says the graph of h of x equals x squared, so I'm going to plug in h of x equals x squared, was transformed to create the graph of k of x equals h of 4x minus 8. I'm going to go plug that in. So let me clear all those. H of x equals x squared. K of x equals h parentheses 4x minus 8. I'm going to reset it because I'm zoomed out a lot. Okay, so there's my two graphs. It says the graphs of h of x and k of x have the same axis of symmetry. Is this true? Well, remember your axis of symmetry has to go through your vertex. So here's my vertex on this one. Here's my vertex on this one. Remember your axis of symmetry is your x equals and the x on your vertex. The x on this vertex is 0. The x on this vertex is 0. So for both of them, their axis of symmetry would be x equals 0. So this one is true. This one says h of x was shifted 4 units to the right. First of all, you can do it just by looking here, or you can look at your graph. It wasn't moved left or right, so that's automatically out. Says the vertex of k of x is 8 units lower. Did I move it down 8? First of all, if you know your rules, then minus 8 already means move down 8. But you can even see it here. This one was at 0, 0. Now it's at 0, negative 8. So yes, it did move down 8. Says the graph of h of x was shifted 8 units up. We already said nah. It was horizontally compressed or it was horizontally stretched. This one, remember h of x, normally if you multiply by a number bigger than 1, you would think stretch, but inside of your parentheses is opposite, so it should be a horizontal compression. Bing, bang, done. I think that's the quickest